Okay, this is the third part here. This is the free response that you were working on in pairs. So let's look at what you have and compare it to the essentially correct answer. So these are essentially correct, so if you missed something in here, I'd like for you to go ahead and correct it and kind of look at what you put and see what you missed. So an airline estimates the probability that a random call to the reservation phone line results in a reservation being made 0.31 or 31% of the time. This can be expressed as probability that a call results in a reservation equals 0.31. Assume each call is independent of other calls. So, if a reservation is made on one call, that doesn't change the probability that a reservation is made the next time. So A says, describe what the law of large numbers says in the context of this probability. So remember, probability is all about the long run, or all about over time. So you want to start this sentence with, in the long run or over time, we would expect a call to result in a reservation approximately 31% of the time. So again, over time, the more calls we get, it's going to get closer and closer to that probability, which is 0.31 or 31%. So if we only take a couple calls, it may not be close to that percentage. If we take more and more, then we will continue to approach that percentage. It's the same thing like flipping a coin, heads or tails. 50% is the probability, but if you just do it a couple times, again, you may not get that 50%, but in the long run, we would expect to get there. So again, the key words are in the long run, we would expect, and then approximately 31% of the time. Okay. B, what is the probability that none of the next 4 calls results in a reservation? Well, if you look here, the probability that a call results in a reservation is 0.31. So to find the probability that a single call does not result in a reservation, that's 0.69. So we know 69% of the time we get a call and we don't get a reservation out of that call. So for the next 4 calls to not result in a reservation, that would be 0.69 times 0.69 times 0.69 times 0.69. So you would multiply those because you need all 4 to happen, and that equals 0.2267. So there's a little bit over a 22% chance that none of the next 4 calls will result in a reservation. In part C, this is now we go to a simulation here, so this goes into a little bit more detail. I remember simulation was in section 1, so it kind of brings it all together. You want to estimate the probability that exactly, so that's a key word there, exactly one of the next 4 calls result in a reservation being made. Describe the design of a simulation. Explain clearly how you will use the table of random digits below to carry out your simulation. So I'm kind of helping you here, but remember, 31% result in a reservation, so we will assign numbers 0, 0 to 30 to result in reservation. That's 31 numbers. And then 69% do not result in a reservation, so we're going to assign the other 69 numbers here, 31 to 99, to mean no reservation. We're going to start on line 188 because that's the first line that we're given down below, and we want exactly one of the next 4 calls. So we're only going to look at 4 calls, so we're going to write 4 numbers would equal a trial. And if you look at D, it says carry out 5 trials. So the first trial would be 87, 37, 08, and 80. There's one number, 08 is the number that is within 0, 0 to 30, so that would mean that 1 call resulted in a reservation. So we put a check because that's what we're looking for. We're looking for exactly one of the next 4 calls to result in a reservation. The second trial, we get 99, 89, 69, and 58. All of those are in the no reservation category, so no calls resulted in a reservation. The next one, we get 76, 33, 76, and 98. Again, no calls resulted in a reservation. The next trial, we get these 4 numbers. 03 and 26 are 2 that would result in a reservation. 25 and 17 are 2 that would result in a reservation. So out of our 5 trials, only once did we get 1 call, which was what we were looking for in our problem. So we get that the probability of getting exactly 1 call is 1 out of 5 because it happened once in our 5 trials, and that's 0.20, which means there's a 20% chance of exactly one of the next 4 calls being a reservation being made. Now, if you start on another line, you could have gotten a different answer. But as long as you showed your work and showed what you did, notice how I underlined the numbers I used, circled them, then it will work. There's definitely going to be a simulation problem like this on the test Wednesday, so make sure if you have any questions with it that you follow through with me, and make sure you ask some of your neighbors about what to do there. Okay? Alright, moving to number 12. Number 12 says that a grocery store examines its shoppers' product selection and calculates the following. The probability that a randomly chosen shopper buys apples is 0.21, that they buy potato chips is 0.36, and that they buy both apples and potato chips is 0.09. So we start with the both, the 0.09. And then we have the apples here, which is 0.12, because we need all this to be 0.21, and then this is 0.27 because we need all of the potato chips to be 0.36. When we add these three numbers together, we get 0.48, which means the probability of not getting apples or potato chips is 0.52. And then in part 1, the probability that a randomly selected shopper buys apples or potato chips. So again, if they buy apples or potato chips, we have to take the probability of buying apples plus the probability of buying potato chips minus the probability of buying both. I get 0.21 plus 0.36 minus 0.09, and that gives me, these are 0.57, and then minus 0.09 gives me 0.48. Now, again, it says the probability that a randomly selected shopper buys apples or potato chips. You could just see this is the probability that they don't buy them. So 1 minus that also gives you 0.48. So remember, you can do it a number of ways. You could have actually added up these three numbers here and got the same thing. So a lot of different ways to do that, but that is your answer, is 0.48. Number 2. Probability that a randomly selected shopper, I skipped number 2 because we didn't need that one, so just we'll go back to it later if you need. But number 3, the probability that a randomly selected shopper doesn't buy apples and doesn't buy chips. That's the part, that's the 0.52. That's the part that is 1 minus. So they don't buy apples or chips, so that's the part at the end that we get. Now we're going to move to number 13, which is the tree diagram. Again, like I said last semester, if there was something that that bothered people, it was the tree diagram. That was what they did worse on the test. So we're going to look at those and try to get through any problems you have with that. Okay, I'm going to write this number down here, and I'm going to go ahead and write one more number down as we're going through the problem. Okay. Alright, so let me take you through this. Wile E. Coyote is pursuing the Roadrunner across Great Britain towards Scotland. The Roadrunner chooses his route randomly. There's a probability of 0.8 that he'll take the high road. So there's the Roadrunner taking the high road. There's a 0.2 chance that he'll take the low road. So that's our first tree. Those are our first branches in the tree diagram. 0.8 chance of taking the high road, 0.2 chance of taking the low road. If he takes the high road, which means we're up here at the top, so there's the high road and the low road. It says if he takes the high road, which means we're up here, then there is a 0.01 chance of getting caught. So 0.01 chance of getting caught, which means a 0.99 chance of not getting caught. If he takes the low road, there's a 0.05 chance of getting caught, which means there's a 0.95 chance of not getting caught. Now, so if we randomly choose a route, the chance that we choose the high road and get caught is 0.8 times 0.01, so it's 0.008. If we randomly choose a route, the chance of choosing the high road and not getting caught is 0.8 times 0.99, which is 0.792. If we randomly choose a route, the probability of choosing the low road and getting caught is 0.2 times 0.05, which is 0.01. And if we randomly choose a route, the probability of choosing the low road and not getting caught is 0.2 times 0.95, which is 0.19. If you notice, all 4 of these will add up to 1. Those are all your possibilities. So you get these numbers out here by multiplying these. Alright? Now, find the probability that he took the high road given that he was caught. So we know that he was caught, and that only happens in these two. So I'm going to circle those because that's all we're talking about. We are not talking about these two because those are when he was not caught, and this says we are given that he was caught. So we actually know he was caught. So our denominator is just these two, and that adds up to 0.018. And we want to find the probability that he took the high road. So this one is the high road, this one is the low road. So we want the high road over our total number. So 0.008 over the total of these two gives us the probability that he took the high road given that he was caught. And you can find that by just plugging that in the calculator. So again, a little bit trickier on the tree diagrams, but you have to write out the branches and multiply to get the final numbers. Anytime it says given, you know that you're only dealing with what you're given, so you're not dealing with the rest. We'll go over another one of these problems later, but if you still have questions with it, make sure you ask me, put it on a sticky note, so that I have the sticky notes at the front of the classroom. That way I know you have a question with it, and I'll be sure to catch you in my video tomorrow for the test review. If you do have a question and you don't write a sticky note, then I won't be able to know that, and I won't be able to go through it. So make sure you use the sticky notes up there if you need me to go over something before tomorrow. Alright, that takes care of the free response. So the next thing we're going to do is the it says quiz 5.3a. It's going to be your lesson for today, and after that you'll be able to work on your homework. So if you'll get out quiz 5.3a, and we're going to go through that together.